Okay, in question 11, we got this block being pushed along the floor by a constant applied force that's horizontal, and they give us the magnitude, and then they give us the block speed versus time as it moves along the x-axis. They want you to find coefficient of kinetic friction. So here is a reproduction of that little plot, and we've got an object. So it's on the floor, and actually, let me draw this a little smaller. There we go. Okay, so it's got some mass. It's being pushed by some force F, and let's see, there's a normal force on it. It's going to have gravity, and then of course there's going to be a friction force acting on it because there was friction. Okay, so and it's got some acceleration that way, but we don't know what it is. Well, actually, it's not very hard to figure out what that acceleration is, right? Because here's our plot, velocity versus time. Now, if we have a velocity versus time plot, how do we get acceleration? It's the slope. So, very easy. Change of acceleration is delta v over delta t. And what's our change of velocity here? Well, it looks like we start, so that would be like 1.0 right there. But we actually start there at 0.5 meters per second. And then we end up here, which is 2 boxes above 4. And it looks like each box is, or like 2 boxes is 1 meter per second. So 3 would be right there, 4, and then 5. Okay, so change in velocity then is 5 minus 0.5, which is 4.5 meters per second. And the time was 1.0 seconds. So acceleration is 4.5 meters per second squared. Okay, so now let's go and take our block and do our free body diagram on the block. So, as usual, x and y, and here we go. Normal force, mg, friction force, and our applied force F, which we were given. Okay, so as I think we're getting used to this by now, if we have friction, we know we're going to need the normal force, and we know we're not accelerating in y, so let's go ahead and do y first. Not accelerating in y, so sum of forces in y is 0. So that means n minus mg equals 0, which means n equals mg. And, it's up to you whether you want to do the x-force balance or just calculate friction force first. I guess this time we'll just do friction force first. So mu k times n is the friction force, right, which is mu k mg. So now let's do our sum of forces in the x direction, which is going to equal ma, because a is going to the right and positive x is to the right. So that's all good. Applied force F minus friction force equals ma, but of course we know the friction force. So F minus mu k mg equals ma. And we want to solve for mu k, so let's get, how do we do this? Let's see. Let's do, all right, let's just do, let's see. Why don't we do F minus ma equals mu k mg, and then we divide both sides by mg. So then we could have F over mg minus a over g equals mu k. And that should be enough for you to solve for mu k. So there we go. And how much time do I have? I have quite a bit of time left. So let me see if I can squeeze problem 12 into this video. Nah, you know what? Let me just stop and you can load another page and do another video. It won't kill you.